Here's a trig equation that we're going to solve. 3 cosine pi over 5x equals 2. Now every time I solve a trig equation where the coefficient in front of the angle variable is not 1, I do a substitution. I let u equal pi over 5x, and I solve the equation that corresponds. 3 cosine u equals 2. And I'm going to solve this for all values of x. Not just in the first rotation, just all the values of x. In order to solve this guy, I'm going to divide both sides by 3. And I notice that 2/3 is not a standard angle. That is not on the unit circle. So I can solve it 2 different ways. So method 1. I can take the cosine inverse of both sides, and I have u right away. U equals cosine inverse of 2 over 3. Now technically speaking, that's only giving me one angle right here. So this is the angle u in the first quadrant. Now cosine is positive again in the fourth quadrant, where this angle right here is also u as a reference angle. Okay, so that means if I want the angle starting here and rotating all the way around, I have to take u equals 2 pi minus that initial angle, cosine inverse of 2/3. So now I have my 2 angles in the first rotation, and in order to get all the angles in the first rotation, I just add 2 pi k to each. So u equals cosine inverse of 2/3 plus 2 pi k. That accounts for all the rotations around and around. And u equals 2 pi minus cosine inverse of 2/3 plus 2 pi k, where k is an integer. Don't forget to put that. A lot of students want to leave it off because they don't think it's important, but there's a difference between k being an integer and k being a real number. So there's my 2 solutions for u, but actually I want all values of x. So that means I have to substitute in pi over 5 x in for u and then solve from there. So cosine inverse of 2/3 plus 2 pi k. Same thing over here, pi over 5x equals 2 pi minus cosine inverse of 2/3 plus 2 pi k. Now in order to isolate x in both of these, I'm going to multiply by the reciprocal of this guy. So multiply both sides by pi over 5. I'm sorry, not pi over 5, 5 over pi. 5 over pi cosine inverse of 2/3 plus 5 over pi times 2 pi k. Same thing here. X is 5 over pi, 2 pi, minus 5 over pi cosine inverse of 2/3 plus 5 over pi of 2 pi k. Now I can simplify what I can. As a lot of students want to be sticking stuff in their calculators, I try not to use the calculator until the very end. So that's going to stay plus, now these pi's cancel and I'm left with 10k. And over here, these pi's cancel and I'm left with 10 minus 5 pi cosine inverse of 2/3 plus, again, this is going to be 10k, where k is an integer. So there's my 2 solutions right there. You can pop this bit in your calculator and get a decimal approximation, and pop this bit in the calculator and get a decimal approximation. The 10k has to stay as is because it's got the k in it. But from there, you can approximate it if you need, but this is what you call exact values here. Now that's method 1, using the cosine inverse function. Method 2 is kind of a favorite among students as well. Method 1 isn't as happy for students. So in the end, I'm trying to solve cosine u of 2/3. Whoops, let me rewrite that. Cosine u equals 2/3, where u is also equal to pi over 5x. Now a lot of students use the graphing method, where they're going to let y1 equal cosine u and y2 equal 2/3. And then see where they intersect. The first 2 closest ones, in fact, where they intersect. So let's get my calculator here ready. Go to my y equals and clear everything out. Now notice that this plot here is highlighted, so I'm going to turn it off because I'm not doing a plot. I can go up there and hit enter and it turns it off. But in here, for y1, I'm going to put cosine of x, understanding that I'm meaning u. I don't have a u to type in there. And 2/3. Now I'm going to graph it on one rotation, 6 to 2 pi. I'm sorry, 0 to 2 pi. And the amplitude of this guy is 1. So my y min is going to be minus 1.2. Y max is 1.2, just to make it a little bit bigger. And then let's look for the intersection. So there's my first rotation, 0 to 2 pi. And there's intersection 1 and intersection 2. So let's write this down where the intersections are. So second trace, I go to number 5. And I'm going to tab over a little ways to that first intersection there on the left. And the question it's asking me is first curve. So it's asking me, okay, which one do I consider the first of the two curves we're going to find the intersection between? So I mark it, then it asks second curve, and I hit enter to mark the fact that I want to find the intersection between those two. And my guess, I want to tab over to the closest I can to the intersection. And the number I get is 0.8411. 0.8411. Now let's do the other intersection. Second trace, 5. And again, I'm going to move over towards the other intersection first before I hit enter to answer the question. Again, not being in a hurry is always really helpful here. That way you don't make mistakes. So enter to first curve to mark it. See how it's marked there? And then enter to hit the second curve. And my guess is right over here. And that gives me 5.4421. So u is also equal to 5.4421 in the first rotation. Okay, and notice they're not equidistant apart. So when we do this over here, we have to add our 2 pi k to make sure we get all possible rotations. Now, if you're going to do this on a test, this method, I would suggest strongly that you sketch this graph exactly as is and you label these intersections so that your instructor knows where you're getting this information, that it's not just coming out of your where nether regions. So, excuse me. So, if you're going to say you're going to solve this graphically, show your instructor what you're going to let y1 and y2 equal, sketch the graph on your paper, and then write what you have here. Now, we're not quite done yet. We still have to consider the fact that u is pi over 5x. So let's write that in there. Let's move this guy over. I'm running out of room. Okay. Now, in order to continue to solve for x, I need to multiply by the reciprocal of pi over 5. So that's going to be 5 over pi times 0.8441 plus 5 over pi 2 pi k. X equals 5 over pi 5.4421 plus 5 over pi times 2 pi k. Notice these pi's cancel in both cases. So you can use your calculator now to estimate this. 5 times 0.8441. Oops, that should be 8411. Divided by pi. 1.3387 plus 10k. That simplifies there to 10k. Now over here to this guy, I'm going to input in my calculator that number. So 5, oh, can't see that. Let me move it over. 5 times 5.4421 divided by pi. So 8.6614. 8.6614 plus 10k. So those are all my possible values of x, where k is an integer in both cases. So you can use either method. You can use the method where you have a graph that you should knowingly sketch. Here's a line 2/3. That's 1. You need to mark these points where they're at when you put this on your paper. So this is x and this is cosine of x, or u, I guess, technically speaking. Sketch your graph, label your points to show where you're getting these numbers from. So it's not just a guess for your teacher. You don't want to do that. Or you can use method 1, which is a lot more purely algebraic, but it doesn't matter. Either one works, and you can actually test it. If you type this into your calculator, you should get the same number as you did at the bottom. And same thing here. Type this in your calculator, you should get the same number at the bottom.